In this video, we're going to learn step-by-step method of deriving Bernoulli's equation. First of all, Bernoulli's equation is obtained by integrating Euler's equation of motion. So, and what is Euler's equation of motion? So, in fluid flow, there are forces that act in the fluid flow. So, we have pressure force, force due to pressure, we have force due to gravity, and we have force due to viscosity, force due to turbulence, and force due to compressibility. So when compressibility is negligible, the force due to compressibility is negligible, the equation is Reynolds equation. And when force due to turbulence is negligible, is known as Navier-Stokes equation. And when force due to viscosity is negligible, is known as Euler's equation. So Euler's equation consists of two forces, which is force due to pressure and force due to gravity. I know that according to Newton's law of motion, you have that force is equal to mass times acceleration in the direction of the force. So here we have that the net force, which is the total force acting on the fluid, is the pressure force plus force due to gravity is equal to mass times acceleration in the direction of force. Here we are considering the direction of force is the streamline, because we are considering a differential cylindrical element along the streamline. So, and the distance is given as the S, and the cross-sectional area is given as the A. So the force that is acting on the fluid, you know that force is product of pressure and area. So, and here the cross-sectional area is given in terms of the A. So we have that the pressure times the A will give you the force that acts on the fluid along this direction. And for every reaction that is equal and opposite reaction, so the force that is opposing the fluid flow is given as the change in pressure with distance times area, which is P plus partial P partial S, the S, all in bracket the A, will give you the force that is opposing the fluid flow. And also another force is the force due to gravity. So we have the self weight of the fluid element, which is the weight of the fluid, which is mass times acceleration due to gravity, and mass is given as density times volume. So the volume is area times distance, which is the ADS. You have rho the ADS times G will give you the self weight of the fluid element, so which is inclined at angle theta. So when you resolve this horizontally, when you resolve this along this line, you have rho the ADS times G cos theta, and theta here is given as here is the S, and this line is the Z. So this point is opposite facing this angle theta. So we have that cos theta will be equals to this line, which is the Z, over the S. So we're going to apply this later in the equation, in the solution. So now we have that the net force is force due to pressure plus force due to gravity equals to m times acceleration in the direction of force. So force due to pressure, the total force due to pressure is P dA minus the opposing force, which is P plus partial P partial S ds, all in bracket, times dA minus the weight of the fluid element, which is rho the ADS G cos theta, equal to mass times acceleration. Then when you open this bracket, have that P times dA will give you P dA. P dA minus P dA will go, we have partial P partial S ds times this, which will give you this. Then you have this the weight of the element here. You have the then this mass now will be density times volume, which is rho the ADS times acceleration in direction of flow. So when these two forces, when P dA minus P dA goes, you have rho P partial S the ADS minus rho d ADS G cos theta is equal to rho the A the S times acceleration is given as dv dt. So you substitute A with dv dt. So and changing velocity here is a function of time and distance. So the velocity changes with time and distance. So you have that v is a function of st. So from your partial derivative, so you don't need to bother. You just need to know the final answer. But for knowledge sake, you have that v is a function of f of, you have that v is equal to f of st. So when you differentiate v with respect to s, keeping t constant, you have dv is equal to partial v partial s, keeping t constant, this the s, plus when you differentiate v with respect to t, keeping s constant, you have partial v partial t, keeping s constant, dt. So if the flow is steady, that means that partial v partial t will be 0. Before then, you divide through by dt. So you have dv dt will be equal to partial v partial s ds over dt plus partial v partial t. So dt will be 1. So if the flow is steady, partial v partial t is 0. So that you have v partial s. You know that ds dt is velocity. That's distance over time. Will give you velocity. So that's how v here. So you substitute dv dt with partial v partial s, so that you have that minus partial p. So this equation here, so you bring down this equation here, which is minus partial p partial s dA ds minus rho dA ds g cos theta equals to rho dA ds v partial s. So replacing dv dt. So the next step is to divide through by rho dA ds. So when rho dA ds divide this term, you have the ds will cancel this remaining rho. You have minus partial p over rho partial s minus, you have minus rho dA ds cancel, divided by rho dA ds. You have this cancel, so you have minus g cos theta. So rho dA ds divided by this, you cancel it out. You have only v partial s, which implies changing this partial to total derivative. We have total differential. You have dp over rho ds plus g dz over ds plus cos theta. Now we now change cos theta to dz ds. From here, you have that cos theta is equal to dz ds. So you place cos theta with dz ds. So you have g dz ds plus v dv ds equals to 0. So to remove the s, you multiply through by the s, so that you have dp over rho plus g dz plus v dv is equal to 0. So this is known as Euler's equation. So this is Euler's equation. So I know that Bernoulli's equation is obtained by integrating Euler's equation. So now we have to integrate this equation. So integral of dp over rho plus integral of g dz plus integral of v dv is equal to constant. So you have the integral, you just simply cancelling out these in the equation. So you have integral of dp over rho will give you p over rho plus integral of g dz will give you gz plus integral of v dv will give you v squared over 2, which is equal to constant. So you can as well rearrange the equation by dividing through by g, so that you have p over rho g plus v squared over 2g plus z is equals to constant. So this is Bernoulli's equation. So this is the step-by-step method of deriving Bernoulli's equation. Please hit the subscribe button for more videos. Thank you for watching.